In this video, we're going to look at solving rational equations. Rational equations have at least one variable in the denominator. This is what distinguishes them from the linear equations that we have looked at previously. So for an example of a rational equation, I have 5 over 2x equals 17 over 18 minus 1 over 3x. Notice that my x's are in the denominator, hence they're rational, not linear. But it's going to work very similar to the linear equation. The first thing I'm going to want to do is find the least common denominator so that I can get rid of the fractions. So I'm looking at 2x, 18, and 3x. Okay? 2 and 3 both go into 18, so 18 is going to be the numerical part, and I have to have an x because I have an x in my list. So 18x is going to be my lovely little magic number that I came up with. He's really just the least common denominator for me. And I'm going to multiply both sides by 18x. On the right-hand side, I'm going to distribute the 18x so that it looks like each term got multiplied by 18x. And that is exactly what it is. When you multiply and distribute, each term gets the factor. So I have each term multiplied by 18x. I'm ready to see if I can make some ones. Why do I call it making one? Because x over x is 1. Any number over itself is 1. Now numerically, 2 goes into 2 one time and into 18 9 times. Move to my next term. 18 goes into 18 one time. I made a 1 out of the 18s. And the final one, 3 goes into 3 one time, into 18 6 times, and x over x is 1. So if I did this correctly, my next line will have no fractions in it. I see on the left 5 times 9. On the right, I have 17 times 1x, which is just 17x, minus 1 times 6, which is 6. So sure enough, I have no fractions left. My x's are on the right, so I want to move all my constants to the left. So since it was minus 6 on the right, I'm going to add 6 to both sides, making it plus 6 on the left. That gives me 51 equals 17x. Since they multiplied my x by 17, I need to divide by 17, and I get that 3 is x. If I have time, I always check these, and I try to make sure I have time. And I'll give you a hint as to why. In this case, most students forget to look and tell me x had better not be 0. Then if they don't check and 0 was what they got for an answer, they've missed the question because they gave me an invalid answer. So I always like to check on rational if in fact I have time. So 5 over 2 times 3 equals 17 over 18 minus 1 over 3 times 3. So this is 5/6 equals 17/18 minus 1/9. 1/9 is 2/18. Write that in so you don't lose you. 1/9 is 2/18. So I'm saying 5/6 is 17/18 minus 2/18, which is 15/18. 15/18 has a common factor of 3 in the numerator and denominator, so I shall divide it out. 15 divided by 3 is 5. 18 divided by 3 is 6. I know that my x equals 3 was the correct answer. And I want to do one more example that some people think is stated kind of strangely, but the reason they do this is because this is the way it comes at us more frequently in real world problems. And that is determine the values for x for which y1 equals y2. In other words, I've got two different situations and I need them to work at the same time. So all that is an equation that says 1 over x plus 4 plus 1 over x minus 4 equals, but when I come over here to the right hand side, I don't want to leave that quadratic there. That is the difference of squares, and it gives conjugate pairs. Now the reason I want to factor it into conjugate pairs is because I need my factors to be able to identify my least common denominator. I can tell by looking that my least common denominator is going to be x plus 4, x minus 4, because if that's it, I've got everybody covered. So I'm going to multiply every term up there by x plus 4, x minus 4. So 1 over x plus 4 times x plus 4x minus 4. Again, if it helps you to write this as a fraction over 1, there's some people who didn't do enough work with fractions and they need that. If that's your case, by all means, write it like that. It will not hurt my feelings at all in your scratch work. And 1 over x minus 4 times x plus 4, x minus 4. That's my left-hand side, equals 22 over x plus 4, x minus 4. Times, that's that whole thing, times x plus 4, x minus 4. Now again, Miss Harrell puts all of this in parentheses because she has a definite rule. You cannot make ones if there's any exposed plus or minus signs. I can't make ones from what's to the left of that plus sign and what's to the right of it because that plus sign is exposed. I can't cross out across the equal sign. So only what's connected through parentheses can I look at making ones, which is what I'm ready to do now. So on this left one, x plus 4 in parentheses cancels with x plus 4 in parentheses because they make a 1. Any number over itself is 1. And what that leaves me here is just x minus 4 plus. Okay, my second term on that side, x minus 4 in parentheses over x minus 4 in parentheses is 1. Any number over itself is 1. And what that leaves me is x plus 4 equals, on the right hand side of the equation, x plus 4 over itself is 1, x minus 4 over itself is 1. That leaves me very simply with 22. Now x plus x is 2x. Negative 4 plus 4 is 0. And I have 2x equals 22. Since they multiply by 2, I divide by 2. X is 11. Now I still want to check because I didn't state my exclusions to begin with. So I need to be certain of two things. Number one, x minus 11 doesn't cause the denominator to be 0. Number two, that the arithmetic would work. So if I substitute 11, 11 plus 4 is 15. 11 minus 4 is 7. And 11 squared is 121 minus 16 is 105. Now I'm going to do the old, I called it the butterfly method. I don't know what your teachers would have called it. where I'm going to simplify two fractions in addition to easy extent. 7 times 1 is 7. Multiplying up the other way, 15 times 1 is 15. And then multiplying my denominators, 15 times 7 is 105. And 7 and 15 is 22. And I do end up with 22 over 105 equals 22 over 105. Nobody promised you that it would be easy or even really neat. But I promise you, when this checks, this is correct.